This is 3-3, and in this section, we're finding the rate of change in slope. So rate of change is a ratio that describes, on average, how much one quantity changes with respect to another quantity. And then we have rate of change. The formula is change in y over change in x, and it's almost just, it really is the same thing as slope, because that's also what slope is, change in y over change in x. The actual definition of slope is the steepness of a line, and another way of looking at slope is rise over run. So for number 1 and 2, we're going to find the slope of a line that passes through the given points. So at this point, they're giving you the points. So since slope and rate of change are change in y over change in x, how do we determine how something changes? Well, we subtract. Because, for example, if I said, well, how much taller are you now than you were in 6th grade? You would figure out what your height is now and figure out what your height was in 6th grade, and you would subtract them, and that's how you can compare it. So when we're talking about the change in something, it's subtraction. The actual real formula for slope is m equals y2 minus y1 over x2 minus x1. So the y1 and the x1 just has to do with your coordinates. You should have done this last year, but you may not have. I don't know if you actually got to it or didn't. So if I'm going to consider this my first set of coordinates here on number 1, this is my x1 and this is my y1. And if I'm considering this my second set of coordinates, this is my x2 and this is my y2. Really, the most important thing is order. So if you're going to go in this direction for your y, so it's going to be 5 minus 0, so m equals 5 minus 0, then you have to go in the same direction for your x. So on the bottom, you're doing 1 minus negative 2. Pay attention to that 1 minus negative 2 part. That becomes a plus, and we're left with 5 over 3. So our slope is 5 over 3, which means if you were to graph those 2 points, how you can get from one point to the other is to count up 5 and over 3. All right, so we're going to do the same thing with number 2. So it's change in y over change in x, or y2 minus y1 over x2 minus x1. So I'm going to do this minus this. So negative 1 minus negative 1 on the top, and 2 minus negative 3 on the bottom. And again, order does not really matter in a way, because I could have started over here and gone in this direction if I wanted to. What does matter is on the top you have all y's and on the bottom you have all x's. And the other thing that matters is if you start in whatever direction you start in for the top, you have to start in the same direction for the bottom. So that turns into a plus and that turns into a plus. So negative 1 plus 1 is 0, and 2 plus 3 is 5, and I have a problem here. Because this is either going to be a 0 slope or it's going to be an undefined slope, or sometimes they call it no slope. In this case, the way I can figure it out is if I were to maybe turn it into an equation. And remember, for equations, we work backwards and do the opposite. So is there a number that I can multiply by 5 and that would give me 0? Well, yes, it's 0. So this is a 0 slope. Now, an undefined slope would be if I had 0 on the bottom. So for example, this is just example, if I had done the math and I wound up with 6 over 3, if I were to turn that into an equation again, is there a number that I could multiply by 0 that would give me 6? No, there is none. It can't happen. So this is undefined. When that happens, undefined. When that happens, 0 slope. You have to say the difference. There is a difference between the two, and you have to say which is which. And on the back, I'm going to show you the difference between the two. All right, next one, find the value of r so that the line going through 1, 4 and negative 5r has a slope of negative 1/3. Okay, so this one, they're giving you the slope, and we're finding the missing point, the missing coordinate. So we're going to use that formula. So the formula m equals y2 minus y1 over x2 minus x1. We're using that formula. They already gave me my slope as 1/3. So 1/3 equals, so on the top I'm subtracting my y's, so r minus 4. On the bottom I'm subtracting my x's, negative 5 minus 1. Simplify. So I'm going to simplify the bottom, because the top, obviously there's nothing I could do with r minus 4. And on the bottom that gives me negative 6. So now I can solve this like a proportion. So I'm going to cross multiply. So 3 times r minus 4 equals negative 6. So if you're not sure where I got that from, I cross multiplied here. And now I'm going to do the distributive property, and I'm just going to solve it. So r equals 2. So that was my missing coordinate. So this coordinate should be -5, 2. All right, and then down here, some word problems. This needs to be added in here. So the table shows the population density for the state of Texas in various years in thousands. Find the average annual rate of change in the population density from 2000 to 2009. So we only care about these years. Even though they gave us other years, this is all we're focusing on because that's what they asked. So this is my X and this is my Y. Well, how do I know that? Because the Y is dependent on the X here. The population depends on the year. So your independent and your dependent variables are your X's and your Y's. The Y is dependent on the X, always. So I know that I'm going to do 96.7 minus 79.6. That's going to be on the top because that's my Y. And on the bottom, it's 2009 minus 2000. Simplify that. I get 17.1 over 9. And when I divide the top by the bottom, I'm going to get 1.9. So to answer the question, find the average annual rate of change in the population. So since they're asking me for the rate of change, I still have to say whether it goes up or down. So there is an increase of 1.9 thousand people per square mile. This is your answer. This per is very important because when we have a comparison here, a ratio is a comparison of two numbers, it's going to be something per something. This word per is what relates them. So I took the words in my answer right from here. So people per square mile. All right. So number 5. Number 5 is an easy one. The roadway signs such as the one below are used to warn drivers of upcoming steep downgrade that could lead to a dangerous situation. What is the grade or slope of the hill described on the sign? All right, well, they're already telling you 8%. So rise over run, even though the truck is going down, we don't know. It depends on which way you're driving. You could be driving up that hill just as well as down that hill, so we're going to go with a positive. So I'm going to make 8% into a fraction. And then all I'm going to do is simplify it. And why would I want it to be a fraction? Because slope is a ratio, a comparison of two numbers, rise over run. So if the hill was in feet, it would mean that the hill rises 2 feet for every 25 feet horizontally. And then on the back, just simple types of slope, which I believe you should know this already. This is a positive slope and this is a negative slope. And I know that because this goes up from left to right. And if you still have a hard time visualizing that, if you write the word slope on the line, see how it's going up? And you could write the word slope on this line and it goes down. The reason why that trick works is because I read from left to right and I look at the line from left to right. Okay, so now we have zero slope and undefined slope. So this one is a zero slope. And here's my shortcut for that. Make a z out of it. This one is zero slope. This one, undefined, I can make a u out of it. Don't forget, undefined is when I have a zero if I were to do the slope like we did on the front. So an undefined slope is when a zero is on the bottom of the fraction. A zero slope is when the zero is on the top of the fraction. You don't have to memorize that. You just have to think about it logically and mathematically, and then you won't have to memorize it. And that's it.